Hey guys, welcome back to Car Academy. In this video, we are going to take a look at the interview question and see how we are going to solve this two-sum problem. So the problem description is that you are given an array of integers nums and an integer target and return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So let's take an example. So let's say you have an array nums which has this four numbers 2, 7, 11, 15, and we are given a target 9. Okay, so in this case we'll have to check each and every number. So we'll be implementing this problem in two different methods. First with the brute force technique, and next we'll take a look at how we can implement the same in an optimized manner. Okay, so first let's try to understand the problem here. So let's take the first example. So the first example looks like this. You have an array with four elements. So the first element is 2 and second element is 7, and then we have 11 and we have 15. Okay, and the target is 9. So by intuition we can say that by adding these two numbers 2 and 7 we can obtain the target 9, right? By adding these two numbers we'll get 9. Now we are going to see programmatically how to get this. So let's look at the brute force method. So in brute force method we'll take each number and then we'll add with every other number in this array and see if that result equals the target. Okay, so in this example we'll be first taking the number 2 and then comparing that with the number at index 1. So basically take the number at index 0 and then add the number with the number at index 1 and check if that is equal to the target. Okay, so if that is equal, return the two indices. So this is what we will have to return. If not, we'll compare the number at index 0 with the number at index 2. If they both add up and matches with the result, then we'll return those two indices. If not, we'll move to the 0 and 3. Okay, so if that doesn't happen, then what we'll do is we'll take this number at index 1 and then compare that with index 2, number at index 2. If that equals, so we'll go with this approach. So now let's take a look at how to implement this in brute force method, right? Okay, so let's go and implement that. So I have opened this in LeetCode. So the way we do is we do that using two for loops, num start size. So basically you take the first element and in the second loop, so in the outer loop we parse over each element in the array, and in the inner loop we basically go from the next element. That's actually so if the first outer loop is basically at index I, we'll start comparing from I plus 1 in the inner loop. So that's how we will be implementing it. Now what we will be doing is, if nums of I plus nums of j is equal to target, what we will be doing is we'll have to return this, return I and j. That's all. Okay, so if that is not, that doesn't happen, that means that there is no number no two numbers that matches the target. So we'll be just simply returning an empty list. Now let's go and run this. Let's see what happens. So when we have implemented a brute force, in this case what happens is that you have two for loops. It's the solution is O of n squared. Okay, so it says yeah, accepted. Now let's go and try to submit this solution. So let's see what happens when we submit. So this is actually accepted. Okay, so this is optimized, not an optimized solution. It's a brute force solution. Now let's go and implement the brute force solution. So in the brute force solution, we'll be using a hash map. So in the hash map based solution in C++, in order to use hash map, we'll have to use unordered map. Now before I implement that, I will show you how to do that theoretically, right? Okay, so the way we will be doing the optimized method is that this is the optimized method. In this case, we'll be parsing the array only once. Parsing array only once. So what we will be doing is we have some kind of hash map. It's something like this. So we maintain something in this hash map. So what happens is, let's take this example 2, 7, 11 and 15. So we have this 2, 7, 11 and 15, and we have the target 9. Okay, so we first take this number 2, we check, we know our sum has to be 9. So when we read the number 2, we check if there is any number in this map. So this is the hash map. We check if there is any number in the hash map that when we add with 2 that matches to that results into 9. Okay, so when you take 2, we need a number 7. So what we do is we subtract 2 from 9, which is 7, and we check if 7 is present in this hash map. So the hash map is empty at the beginning, so we don't find that. So if we don't find the number, what we do is we store this number 2, which we just read from the array, and we also store its index. So the index for number 2 is 0, and this is 1, this is 2, this is 3, right? So now we have this in the hash map. Now let's go and read the second number 7. Now the target is 9. We have to check if 9 minus 7, which is 2, is present in this hash map. Yeah, we found 2 in this list and in the hash map, and we basically also found the location of that number, which is 0. So now we know 7 is at location 1, and the hash map contains the location of number 2, which is 1, 0. So we can return this in any order as per the problem description. So you can return this as 1, 0 or 0, 1. Either one is accepted. Now let's go and implement this. So now let's go and implement this. The hash map can be implemented with the std unordered map, and now we'll be parsing the array only once. Now we find the difference, target minus nums of I, right? This is the difference, and we will be checking that in the U map, which is the unordered map. Count is basically will return how many such diff are found. If there is one that exists, then we'll get a non-zero value. So we'll check if this is found, then we'll be just returning umap of that diff and the current I. So umap of diff is basically it returns the index. Now you will be wondering how we store this number, right? If it is not found, what happens is we are storing this umap of nums of I is equal to I. So this is the line where we actually, if the difference is not found in that hash map, we are actually storing the current number in the hash map. So it's actually indexed with the number and we are storing the index, right? So now let's go. So finally, let's say after you parse the entire list and if you don't find anything, we simply return an empty list. Now let's go and check this, run this code. Okay, now let's go and submit this. Okay, so this is beating 100% of the code. Okay, so this is the optimized implementation. Comment in the comment below if you have any questions. I will explain if you have any doubts. Okay, so that's all in this video. Thank you everyone. Subscribe to the channel.